Okay, in this video, I'm going to continue to review test to practice problems. So today I'm going to cover the practice problems in chapter 4.3 through 4.4. Okay, so the first problem is in 4.3, problem number 2. So here's a question. The talk time in hours on a cell phone in a month is approximated by the probability density function. So f of x is defined by x minus 10 over 5h for x is between 10 and 15, and then 1 over h for x is between 15 and 20, and then x minus 25 over minus x minus 25 over 5h for x is between 20 and 25. So we have to determine the expected value and variance. So just give me a second. All right, so the f of x, this is 4.3 from number 2, right? So the f of x PDF is defined by a piecewise function, right? X minus 10 over 5h, and then 1 over h, and the x minus 25 over 5h, right? So if x is between 10 and 15, okay, and the x is between 15 and 20, and x is between 20 and 25, right? So the expected value definition of the mean is actually negative infinity to infinity, right? And then x times f of x, right? Okay. So now then what? Since the f of x is defined on 10 to 25, so lower limit, upper limit going to be reduced by 10 to 25. But since f of x is a piecewise function, so definition f of x is different for each integral or subintegral. So we have to divide, break up the integral into 3 subintegral, right? So 10 to 15 x times x minus 10 over 5h, right? And dx, and then plus 15 to 20, and then x times 1 over h, and then dx, and then plus, plus, and then 20 and then 25, and then x times minus x minus 25 over 5h. Okay. All right. So then I believe you can get evaluate each 3 the depth integrals. It's not a big deal. Then you're gonna get the 17.50. Okay. So now next one, v of x. The variance is going to be what? E of expected value of x squared minus mu squared, right? So which is equal to negative infinity to infinity, and the x squared times f of x, and the dx minus mu is expected value. We already got this one, which is this 17.50 in a square. Okay. So then similarly, we're gonna break up that integral into 3 subintegrals. Okay, so 10 to 15, and then what? So x squared times x minus 10 over 5h dx, then plus 15 to 20, and then x squared times 1 over h dx, and then plus 20 and then 25, x squared times minus x minus 25 over 5h dx. Okay. So now the minus 17.50 and square. Okay. Then you're gonna get the yeah. So I believe you can calculate, evaluate these subintegral. I mean, depth integrals. Okay, is you don't have to take care of h. Okay, so this is a depth integral with respect to x. So considering h as a constant, okay, then this is nothing but just polynomial. Okay, so you know how to find the answer to the polynomial, right? So and using fundamental theorem, fundamental theorem calculus in part 2, evaluate. So the answer is 10.42. Okay. So now let's see. Next question is the let's see. The coverage of a base station of a telecommunication company forms a disk with a radius of r kilometers. So let x be the distance of a cell phone from a base station. So assume that the location of cell phones in use are randomly uniformly distributed within the disk. So calculate the mean and variance for the random the variable. So wait a second. Here, let's see. We need to figure out the the probability density function, right? So sorry, excuse me. Yeah, so we need to figure out the probability density function f of x first. So a second. Oh, yeah. No problem. Give me a second. Yeah. Okay. Um, Still. Yeah. Sometimes this webcam doesn't work well. So please understand that. So f of x. I mean, so here the problem says that okay. So the coverage of base station of telecommunication company form a disk with a radius r. Okay, so radius r. All right, and then the x random variable x, the distance of a cell phone from a base station. So and then that random variable is uniformly distributed within a disk. Okay, so uniformly maybe distributed like this. All right. So okay, so then f of x must be the form dc times x. Okay, just a linear function, right? But 0 through the r and then f of x dx must be equal to 1. Remember that the three property of the probability density function. So from that property we can figure out c. Okay, then 0 through the r and then c times x dx which is equal to c times 0 through the r and the x dx, which is equal to c times x squared over 2 and 0 r. So this is equal to c times r squared over 2. That must be equal to 1, right? Okay, so c is what? 2 over r squared. So we figure out that the PDF is going to be 2 over r squared times x. Okay, so now then expected value is going to be 0 through the r and then 2 over r squared times x dx. That must be equal to 2r over 3. Okay, and then v of x, oh, I'm sorry, x times. Okay, so v of x is equal to 0 to r. Oh, yeah, you can say x minus mu square. Okay, dx. But I'm going to use this e of expected value of x squared minus mu square. Okay, so this is going to be what? 0 to r and x squared, and then the 2x over r squared. Okay, this is f of x, right? The dx minus mu square. Okay. So then calculate this, you're gonna get the r squared over 18. Okay. And then let's see, next problem, 4.3.5. This is 4.3.4. All right, determine the mean and variance of random variable. Okay, round variance. Let me skip these problems. I'm sure that you can find the expected value in v of x. Okay, because f of x is given, and the lower limit of, I mean, the range of the random variable is also given, right? And then I'm sure that you know the formula of the e of x and the v of x. Okay, so let me skip these problems. Okay, and the 4.4. So in a paper manufacturing company, a machine is used to press fiber web into a continuous roll of paper. Okay, so this machine does not create a constant pressure on a wet fiber web, and finer sheets of papers have different thickness, which is uniformly distributed between 0.004 and 0.015 inches. Okay, so X denote the thickness of the sheet of paper. Determine the following. Yeah, so all right, so definitely see you have to apply the uniform distribution, right? So give me a second. So give me a second. Yeah, so let me review the PDF and the expected value and variance of the uniform distribution, continuous uniform random variable. Okay, so mu, oops. Okay, so the mu, I mean the f of x is what? The 1 over b minus, I mean PDF f of x is going to be 1 over b minus a, right? And the x is between a and b. Okay, so the mu is the a plus b over 2, and then v of x is the what? That's going to be 1 over b minus a square over 12, right? So in this problem, what the expected value, we're doing 4.4.2, right? Okay. So in that problems, the x is between, I mean, so x is between 0.004, okay, and then 0.015, right? Okay, so this is a and this is b. Okay, so then f of x is going to be b, 1 over b minus a, so we got 1 over, and then let's see, 0.015 minus 0.004, okay, which is 1 over 0.011, right? Okay, but yeah, that's not what we want to find out. Okay, so in question A, we have to find out mu, right? This is going to be what? A plus b over 2, right? So it's just going to be 0.0095, right? Okay, and then b, the variance v of x is going to be b minus a square over 2. Okay. It's going to be 0.015 minus 0.004 square over 2, 12, right? So that's going to be 0.00001. Okay. So now then question B. Question B is what? Proportion of papers. Give me a second. I'll show you the problem. So, okay, proportion of paper sheet which are less than 0.0075 inch thick. Round your answer to 3 decimal places. Okay. So proportion of paper sheet which are less than 0.0075. So what does that mean? Proportion of the paper sheet, it means that probability. Okay, probability uh, of thickness of the sheet paper is less than 0.0075. That's a question. Okay, then what? So we need to find the probability that x is less than or equals. It should be less than, right? So we don't include it equal sign. Less than 0.0075, right? Then what? This is equal to, okay, this is what? This is going to be not x, yeah, x minus 0.0075. See, 0.0075, yeah, 75, right? 75 minus 0.004 over 0.015 minus 0.004. How come? Because probability x is less than a certain value. This is nothing but what? F of 0.0075, which is the CDF. This is a CDF, cumulative density function. And then uniform distribution, I mean, continuous uniform random variable. The CDF, f of x, is defined by, right? I mean, remember that? That is in my lecture note, okay? So that's going to be 0 if x is less than a, and then if x is between a and b, the f of x is defined by x minus a over b minus a. And then otherwise, I mean, x is greater than or equals b, then f of x divided by 1, okay? So because of this one, we're going to get that one. So 0.075, 0.0075, that's going to be x, and then this is a, and then over b minus a, okay? Then we're going to get the 0.31a, okay? And then last question. So thickness exceeded by 5% of the paper sheet. Round your answer to 4 decimal. Okay, so 5% means that 0.05, right? So this is probability. So probability is given, and then we need to figure out the value of random variable. Okay, so let's see. All right, then let me see. All right, so A, B, and C, question C, and then probability that x is greater than x is equal to 0.05, and then we need to figure out x, right? Oh, okay, so now then, this is one, I mean, this guy, x is greater than x, this is equal to, using the complementary rule, we're gonna get 1 minus f of x. Actually, 1 minus f of x, right? Okay, right, that is equal to 0.05. So we use this one. Okay, so 1 minus f of x is equal to 0.05. It means that f of x is equal to what? 0.05. Okay, so now then what? The f of x is what? From the, we only think about the x between a and b. So we're going to plug in x minus a or b minus a into f of x. Okay, so we want to solve what? F of x is equal to 0.05. Okay, but f of x nothing but x minus a over b minus a is equal to 0.05. Right? So we know a, we know b, which are what? 0.004 and the 0.015. You see? Okay. So now then plug them into here and then solve this equation for x, then you're gonna get answer. X is equal to 0.0145. Okay. So now okay. Okay, we're gonna move to next question. So, um, so 4.4.3. Okay. So the beacon transmits a signal every 10 minutes, such as a 20, a 30. The time at which receiver is tuned to detect the beacon is a continuous uniform distribution from 8 a.m. to 9 a.m. So consider the waiting time until the next signal from the beacon is received. Okay, so now we see here are three sub questions there. Okay, so here in this problem, yeah, let's see. I mean, sub question A: is it reasonable to model the waiting time as a continuous uniform distribution? Yes, but the reason that we the waiting time we can consider the waiting time as a continuous uniform distribution, not because of the a beacon transmit a signal every 10 minutes, but the problem says that what time at which receiver is tuned to detect the beacon is continuous uniform distribution from 8 a.m. to 9 a.m. It means that the time is continuous uniform distribution at any interval from between 8 and 9 a.m. 8 to 9. Okay, so that's why the answer is A. This one. Okay, and then B. What is the mean waiting time? Okay, so then we're gonna apply the uniform distribution, right? So here the mu, I mean the f of x mu is what? Is a plus b over 2, right? So let's figure out a and b. So a must be what? 0, and the b must be 10, right? Because we're talking about what? The expected value, I mean, if f of x on any 10 interval whose time length is 10 minutes from 8 to 8, from 8 to 9, right? So a must be 0, b must be 10. So we got 10 over 2, which is 5. Okay. So now then, the variance is sigma square. This, oh, not sigma square, I'm sorry. So next question, that's the answer for the B. Okay. And then C, what is the probability that the waiting time is less than 3 minutes? Okay, so what is the probability that the waiting time is less than 3 minutes? Then, well, we find out, then we find the probability that x is less than 3. Okay, key minus, we're talking about, I mean, whenever x is what? Gonna be what? The 0 to 10, right? Okay, so this is equal to, there's actually f of 3, right? It's gonna be what? 3 minus a, which is 0, over b minus a, 10 minus 0. So we're gonna 0.3. Okay, so that's the answer. All right, and the last question. So 4.4.1. So suppose the difference between actual and predicted weekly sales of a company follows a uniform distribution between negative 4,000 and 4,000. So what is the probability that the actual sale is under predicted by at least 1,500? So yeah, excuse me. So this problems, the x is between negative 4,000 and 4,000, right? Okay, so right, 4,000, 4,000, yes. So probability that in the question A, What is the probability the actual sale is under predicted by at least 1,500? So we find the probability the x is what, less than negative 1,500, right? Okay. So this is equal to f of what? Negative 1,500. Right? So this is equal to negative 1,500 minus negative 4,000. Okay, why? Because this is A, this is B. Okay, so over B minus 4,000, which is minus A, which is negative 4,000. Then we're gonna get 0.313. Okay, and then question B, what is the probability that the actual sale is within 1,200 of predicted sale? Okay, so what's the probability that the actual sale is within 1,200? It means that we want to find the probability that x is between negative 1,200 and the 1,200, right? Okay, so now this is equal to what? So in this problem, we can express this one as like this: probability that x is the less than 1,200, okay, minus probability that x is less than negative 1,200. Okay, so now then this is equal to f of 1,200, right, minus CTF of negative 1,200, and this is equal to what? 1,200 minus negative 4,000 over 4,000 minus negative 4,000, minus f of negative 1,200 is going to be negative 1,200. Okay, and then minus negative 4,000 over, and then 4,000 minus negative 4,000. Okay, so now then this is equal to, since these two fractions have the same denominator, we can combine them. Okay, so this is 8,000, and top one going to be what? Because negative 4,000 is a positive 4,000, and then negative 4,000, which is negative 4,000. So cancel them out. So we got the what? 1,200 minus 1,200. Okay, this is going to be 0.300. Okay, from here we can figure out. So we can figure out the formula for finding this kind of probability under the uniform distribution. So a probability that x is between alpha and beta, okay, under the uniform distribution, this is equal to what? Actually, what the beta minus alpha over b minus a. Okay, so it can be on. Yeah, you can apply this one. Okay, or you just do like this. Either one just fine. So today I just covered the problems in 4.3, chapter 4.3 and 4.5, 4.4. Okay, so next video I'm gonna cover the rest of the problems in test to practice.